And we're back. And we are going to look at the next unit, chapter 3.3. And for some reason, you may be a little disturbed to learn this about me. Logarithmic functions. I really enjoy logarithmic functions. I don't know why that is, because when I was in your shoes and I was learning these, I learned these in college as well. I did not enjoy them at all. But I have learned the secret recipe to logarithmic functions, the secret sauce, as I call it, the jambalaya logarithmic recipe for logarithmic jambalaya, and I will share it with you. First of all, exponential function. Which is not the Cheverton logarithmic jambalaya recipe, is y equals b to the x, right? We've been doing this for the past couple chapters. And this is the base. And this is the exponent. And this is the answer. I'm sure you're all aware of that. Base, exponent, answer, okay? Now, here's the secret recipe for Cheverton jambalaya. It is log base answer exponent. If you have this memorized or written on a little piece of paper or tattooed to your arm, you will probably get every logarithmic question right, most of them. Because this is the secret to going from logarithmic form to exponential form. And when you're stuck on a problem, most likely you'll have to do this. You'll switch between the two, okay? So let's look at it here. Let's say I have, and you're probably thinking, why do I do these? Let's say we have this equation. Notice a log function lets us solve for the exponent. So when you have x up here in the exponent, it can be really difficult to solve for. And so logarithmic functions are one way to do that. And now let's say I want to evaluate this. Log base 3 of 9 equals x. And I don't know how to do that. I'm stuck. I don't know. I should just give up. Who needs math anyways? So when you're stuck, you shift between exponential form and logarithmic form. So I'm going to rewrite this. Base is this number right here, okay. Exponent is that number, so I guess that's x. And the answer is this number right here, so that's 9. 3 to the x equals 9. 3 to what power will give us 9? X is 2. That's easy, because we use the secret Cheverton recipe to go from logarithmic form to exponential form. Little Cheverton jambalaya gets you there. So this is what we use this for, as we're solving for the exponent. In this case, it's easy. But if you had 3 to the x equals 7, now, holy crap, that is hard to solve for x without using a logarithm. And I'll teach you how to do this so we can get that x value there. But the purpose of these is all to solve for the exponent. That's why we learn on logarithms. Okay? Oh, and let me say also, when I have this, 3 to the x equals 9, I could write this as, as 3 to the x equals 3 squared, right? There's going to be many times when we'll have some complicated function here, but if the bases are the same, what has to be true about the exponents? Yeah, they have to be the same as well. So if you had something terribly ugly, like, I don't know, 2 to the x minus 4 equals 2 to the 3x squared plus 2. What are we going to do? Oh, no. Well, if the bases are equal, the exponents have to be equal. So I could say x minus 4 equals 3x squared minus 2. And now I can try to solve this for x. Move everything over, set it equal to 0, try to factor it, try to complete the square, try to use the quadratic equation. A lot of ways to solve this. This looks impossible, right? This looks really frightening. But if the bases are equal, the exponents have to be equal, and I can just set the exponents equal to each other. Very, very common way to solve these problems, okay? Now, log base 4 of 1. What's that going to be equal to? I don't know. So I'll write it as log base 4 of 1 equals x. And this is the base. So I'm going to write it in exponential form. And this is the exponent. And that's the answer. What exponent, when I raise 4 to it, will give me 1? Not 1/4, because that's the fourth root. That's completely different. The only exponent that turns something to 1 is 0. X is going to be equal to 0. And in fact, whenever you have a log of some base of 1, you're always going to get 0. Okay, and this brings us up to one of the first rules here, that if x equals log base b of 1, which means b to the x, right? Base, exponent, answer. This means x equals 0. So let's get rid of this stuff. Our first rule. Log base b of 1 is always going to give you 0. Okay? Now there's another rule. X equals log base b of b, which means, let's put it in exponential form. B to the x equals b. What exponent will do this? Well, the only exponent that's going to do that is when x is equal to 1. Next rule. Log, that thing is kind of lagging. Base b of b is always going to equal 1. When these two are the same, log to the base 27 of 27. It's going to be equal to 1. Always, always, always. Now let's say x equals log base b of b to the y. Whoa, hold on. So that means, let's apply the rule, base, exponent, answer. So that's going to be base, exponent, and here was the answer. Well, that means x has got to be equal to y. If the bases are equal, the exponents are equal. And so if you ever have anything like log base b of b to the y, the answer is going to be y. Okay? And we'll talk about this more later on why this is true. There's another reason why that's true. But we can just use the secret Cheverton recipe to figure out what all of these mean. Okay, this time we're going to go backwards. I'm going to start with the exponential form. B to the log base b of y. There you go. You see this all the time. Base b and then an exponent is a log to the base b of y. Yeah, that's kind of weird, right? But let's write this in log form. So log, our base is b, our answer is x, and our exponent is this big old dude up here, right? Well, so what do you think is true? If the bases are equal in logarithms, what do you think is true about x and y? Yep, they're always going to be equal also. Oh, let me put a little arrow. So our fourth rule is if you have b to the log base b of y, doesn't matter what the numbers are, if the important thing is if this number is the same as that number, then this is just going to spit out a y. Okay? That's a common trick you'll use to solve math problems. So here's our 4 rules for logarithms that we're going to use frequently to solve problems. Here's how I derived them by using the secret Cheverton recipe for logarithm jambalaya. Okay? So we want to keep these in mind. You should be able to prove them by doing these steps that I just did, by writing the logarithmic side, writing it in exponential form, and then usually when you go from logarithmic to exponential, or in this case, exponential to logarithmic, the answer just kind of falls on your feet there, whether you know you're going to find it or not. Okay? Now, we have some special logarithms. They deserve to be special. Okay, so if you have log to the base 10 of x, this is referred to as a common log. And in fact, it's so common that it gets its own little symbol, log x. When there's no base down here, it means it's base 10, okay? When the base is not mentioned, it's just base 10 and you treat it as base 10. Now, if you had log to the base e, remember we talked about e? It was 2.71, blah, 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 and it was some very complicated limit equation thing. It's just a number, but it's used a lot, enough so that it gets its own logarithmic function as well. When you have something log to the base e, this is referred to as natural log. That does not start with an L. Oh, I can't spell. Is that, yeah, natural log. And that's written as ln of x. ln is natural log, and natural log, L. Okay, so these are special logarithms that we need to be aware of. If you see them, you can always stick the base in there if you want. So log of 1, what's that equal to? Well, I'm going to write that as log base 10 of 1, and then I'm going to write it in exponential form. So the base is 10, the exponent is x, and the answer is 1. Well, so that looks like x has got to be 0, right? So log of 1 equals 0. Okay, so let's go back and do log of 10. Oh, that'll be fun. So that means log of base 10 of 10, set it equal to x, change it to exponential form, base, exponent, answer. 10 to the x equals 10. What do you think that's equal to? The bases are the same, the exponents have to be the same. Log of 10 equals 1. Soon you're going to see the pattern and realize why common logs are really useful. Log of 100. Well, that's going to be log, whoa, my 0 got out of control. Log base 10 of 100. And when I write that in exponential form, base, exponent, answer, well, let me write that as 10 to the x equals, that would be 10 squared, right? If the bases are x equal, the exponents must be equal. Log of 100 equals 2. Huh, there's a coincidence. There's 2 zeros. How about that? Never noticed that before. Okay. Log of 1,000. So that would be log base 10 of 1,000. I used the Cheverton jambalaya recipe. Whoops. Equals x. Now I use the Cheverton secret formula. Base exponent equals answer. Wait, can't I write that as 10 to the x equals 10 times 10 is 100 times 10 is 1,000? Yeah, that's 10 to the third power. Well, if the bases are equal, the exponents have to be equal. So log of 1,000 is equal to 3, right? X is equal to 3. X is what we were looking for. So do you see a pattern? When you're doing natural log and you're doing tens and hundreds and thousands and whatever, log of 10,000, 1, 2, 3, 4, is going to be 4 because the base is 10. So this is a property of common logs that you should be aware of. Okay. Let's do some examples. Okay, so let's try this. 5 to the log base 5 of 8. What's that going to equal? Well, let's pretend you don't know. Then I'll stick an x there. And this is an exponential form. I'm going to change it to logarithmic form. Log, my base is 5. My answer is x. And my exponent is that thing. If two logarithms, if the bases are equal, those things must be equal. So x is equal to 8, which we knew that because that was one of the rules, right? So we know that. Okay. There's my cat flying through the air. Let's look at natural logs. So log base e of x, so that's ln of x. So ln of 1 is what? Well, that's log base e of 1. So that would mean change it to exponential form. E to the x equals 1. What exponent will turn anything to 1? And of course, that's 0. So ln of 1, come on, there you go, equals 0. Okay, now what is ln of e? Well, that would be log base e of e equals x. When these are the same, that's one of the rules. But if I write it in exponential form, e to the x, base, exponent, answer. And there's a 1, then they don't need to show it, but really we got an exponent of 1 there. So bases are equal, exponents have to be equal. Oops. Natural log of e is going to be 1. Okay. Now how about, let's go back to red. ln of e to the y. Okay. So I'll write that as log base e of e to the y equals x. And then I'll write that in exponential form, base, exponent, answer. If the bases are equal, the exponents have to be equal. So this would all equal y, right? X comes out to be y, so this thing is equal to y. ln of e to the y equals y. So you see how similar these are to the rules for common logs, because it's the same thing, it's just the base is different. And instead of using tens, we're using e's because that's the base here. Okay. Now, let's actually try a problem. What's square root or natural log of square root of e? First of all, you cannot square this. You cannot square both sides and say this is ln of e equals x squared. No, 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 nay, you cannot do that because this square root is inside a function. So when you've squared this, oops, sorry, like that, when you square it, all you're saying is ln of square root of e. Did I do that right? Yeah. Times ln of square root of e. Well, you haven't really helped anything. This was not an improvement because you cannot square root a logarithm and have an effect on the stuff inside. Okay, so we don't want that. And we don't want that. So this is going to be what? Well, I'm going to write this as ln of, what happened? Oh, wrong thing. Sorry. ln of e to the 1/2 equals x, right? That's the square root is the same as e to the 1/2. Let me write that a little better. Now I can write this as log base e of e to the 1/2 equals x. And let's write it in exponential form. Base, exponent, answer. Bases are equal. Exponents have to be equal. This thing is equal to 1/2. Does that make sense? Okay, let's look at another one. Here's 3 for you to consider. Log base 3 of 81 equals what? So what do you do? That I don't even, that's base 3, it's not base e, it's not base 10. I don't know, what do we do with that? Well, we set it equal to x, and we change it from logarithmic form to exponential form. Base, exponent, answer. What is that, a bug on my screen? Yeah, it is. Okay, sorry, bug. So 3 to the x equals 81. Well, these aren't the same. That's 81 to the first power, and oh my God, what do we do? Well, we got to change this to a base 3 somehow. And I know 81 is equal to 9 times 9. And that's equal to 3 times 3 times 3 times 3. Oh, 81 is equal to 3 to the 4th. Oops. Right? 1, 2, 3, 4. So 3 to the x equals 3 to the 4th. X equals 4. So that's this. So you got to force the bases to be the same so you can equate the exponent. Very common problem-solving strategy for these. ln e to the minus 4. What do you think this is going to be based on what we just did? Yeah, it's going to be minus 4. If you had log base 10 of 10 to the minus 4th, yeah, that's also going to be minus 4. When the bases are equal, you just get that exponent. So the same thing here, that's going to be minus 4. Now, if you don't believe me, well, you're calling me a liar. It's kind of rude, but that's okay. Log base e of e to the minus 4. Set it equal to x, and now let's write it in exponential form. So base, exponent, answer. Bases are equal, so the exponents must be equal. So sure enough, we get minus 4. Last one. 10 to the log 14. What's that equal to? Well, I set it equal to x. It's in exponential form, and I'm confused, so I'm going to convert it to logarithmic form. So it would be log base 10. Here's the base. Here's the answer. And here's the exponent. And as you recall, log base 10 of x, I can write this. There's no number here. It's common log, but that means it's base 10. We just don't have to write it because we're cool. Okay, the logarithms on the bases are the same, so then these numbers must be the same. 14. Okay? So for the most part, the homework is going to be just going back and forth between exponential form and logarithmic form. And the better you get at that, the better you're going to be on doing these logarithmic and exponential type problems. Okay? So make sure you work that out. Make sure you're comfortable about that. Hello, Kitty. Where are you going? And get on the homework. Come in and ask for help. Don't do poorly on a quiz or a test because you're afraid to come ask for help. Please come ask for help. I'm begging you, come ask for help. Okay? And oh, no, I thought the cat was going to walk on the computer. And we will see you next time. Bye.